Venus has been a part of popular culture for a long time since it is so bright and visible in the sky, inspiring writing and music. It was called the most beautiful star in the sky by Homer, author of The Iliad and The Odyssey, two of the oldest and most important works in Greek literature. Australian author Shirley Hazzard won the 1980 National Book Critics Circle Award for Fiction with her book, The Transit of Venus, about two orphan sisters. American author John Gray used the planet and its masculine counterpart to explain relationships in his 1992 book, Men Are From Mars, Women Are From Venus. A song called Venus was teen idol Frankie Avalon's first #1 hit when it topped the Billboard Hot 100 chart in 1959. A decade later, a different song called Venus, by the Dutch rock band Shocking Blue topped the charts in several countries. In 1986, British pop group Bananarama had a #1 hit in the US with their cover of the song. More recently, Venus has been a backdrop for video games such as Transhuman Space, Battlezone, and Destiny. And in the Disney animated film The Princess and the Frog, Ray the Firefly falls in love with Venus, the evening star, as he has mistaken it for another firefly. Welcome to Venus, the biggest star in the heaven. Venus, a cloud-covered planet, is frequently referred to as Earth's twin. But as you get a little closer, Venus becomes infernal. The second planet from the Sun, our closest planetary neighbor, has a surface temperature hot enough to melt lead. The Sun appears as only a smear of light from the surface due to the dense atmosphere. In several aspects, it is less like Earth than the antithesis of it. Venus has no seasons at all, spins backward, and has a day that is longer than its year. It may have once been an ocean world that could support life, similar to Earth, but that was at least 1 billion years ago. All surface water was converted to vapor due to a runaway greenhouse effect, which progressively vented into space. High temperatures and pressures smashed the surface of volcanic rock as it currently exists. We can quickly respond with a hard no when asked if Venus' surface is currently likely to support life. Venus may also have lessons to teach us about how life first emerges, whether it is on Earth, in our solar system, or elsewhere in the galaxy. All of the elements are present, or at least, they once were. We could learn what would make other worlds suitable by examining why our neighbor world's habitability went in such a different direction. And even if it seems ludicrous, we can't completely eliminate out life on Venus. Temperature, air pressure, and chemistry are much more congenial up high, in those thick, yellow clouds. Do you know where the name Venus came from? The Sun, the Moon, and the 5 brightest planets, Mercury, Venus, Mars, Jupiter, and Saturn, were among the 7 bright things that the ancient Romans could plainly see in the sky. They gave the items names in honor of their most revered deities. After the Sun and Moon, Venus, the 3rd brightest object, was named for the Roman goddess of love and beauty. It is the only planet with a female god as its name. Venus's surface has an average temperature of 900 degrees Fahrenheit, or 475 degrees Celsius. Temperatures about 30 miles up, approximately 50 kilometers, range from 86 to 158 Fahrenheit, or 30 to 70 Celsius, which, even at the upper end, might support earthly life, including extremophile microorganisms. Additionally, the air pressure there is comparable to that on Earth's surface. Another transformation can be seen at the tops of Venus clouds, which are being blown about the planet by winds that can reach 224 miles, or 360 kilometers, per hour. Dark streaks continue to appear. Scientists have not yet been able to determine why these streaks hold steadfastly in place despite hurricane-force winds. They also have the peculiar habit of absorbing ultraviolet radiation. Fine particles, ice crystals, or even a chemical substance called iron chloride are the most plausible candidates for the causes. Astrobiologists also speculate that these streaks may contain microbial life similar to that seen on Venus, albeit this is considerably less plausible. Astrobiologists point out that sulfur atoms known to form ring-shaped connections in Venus' atmosphere could give bacteria a protective covering that would shield them from sulfuric acid. In addition to absorbing potentially harmful ultraviolet radiation, these practical chemical cloaks would also re-radiate it as visible light. In fact, some of the Russian Venera spacecraft found particles in Venus' lower atmosphere that were about a micron long, roughly the same size as an Earth bacteria. None of these discoveries offer strong proof that there is life in Venus clouds. However, the issues they bring up, together with Venus' extinct ocean, its ferociously volcanic surface, and its horrific past, provide compelling evidence for a visit to our erratic sister planet. It appears that she has a lot to teach us. Venus is located between 66,783,112 and 67,691,556 miles, or 107,477,000 to 108,939,000 kilometers, from the Sun. Venus is around 38 million miles, equivalent to 61 million kilometers, from Earth at its closest. However, Mercury, the innermost planet, actually spends more time close to Earth than Venus. The two planets are often farther apart. Venus' appearance when viewed through binoculars or a telescope adds another perspective trick. If you keep an eye on Venus for several months, you'll observe that it goes through the same lunar phases as our Moon, full, half, quarter, etc. However, the entire cycle, from fresh to full, takes 584 days, whereas our Moon only takes a month. And it was this viewpoint, the Venus phases that Galileo first saw via his telescope, that served as the foundational evidence for the Copernican heliocentric view of the solar system in terms of science. The duration of a day on Venus would be 243 Earth days, which is longer than a Venus year, one orbit around the Sun, which lasts just 225 Earth days. This would make for a very confused experience. The dawn and sunset on Venus are another unusual occurrence. It would take 117 Earth days to go from dawn to sunset due to the planet's extraordinarily sluggish rotation. And the Sun would rise in the west and set in the east, because Venus spins backward compared to Earth. Venus has no seasons. Only 3 degrees of tilt, which is far too minimal to establish discernible seasons. Venus lacks a moon and a ring. Venus and Earth would astonishingly resemble one another if we were to cut them in half from pole to pole and set them side by side. Each planet has an iron core that is encased in a heated rock mantle. The outermost skin, which is the thinnest, is composed of rocky material. Due to the pressure and heat deep underneath, the thin skin of both planets can change shape and occasionally explode as volcanoes. Radar was used to scan the scorching surface by NASA's Magellan probe, which completed a 5-year mission to Venus in 1994. Magellan observed a region with intense volcanism. The orbiter observed a surface that was geologically young, newly altered, and covered in long chains of high mountains. Venus's scorching surface has generated a lot of debate among planetary scientists. According to the conventional theory, between 350 and 750 million years ago there was a catastrophic, global resurfacing. In other words, the majority of the remnants of Venus' early surface seem to have been utterly lost. The underlying factors include volcanic and tectonic forces, which may result in surface buckling and enormous eruptions. However, more recent projections supported by computer models present a different picture. Even though the same factors would be at play, resurfacing would occur gradually over a long period of time. With some older surfaces mixed in, the average age of surface characteristics may be as low as 150 million years. Venus has a terrain made up of many volcanoes scattered throughout high mountains and valleys. Ishtar Terra, Iraqi, mountainous territory roughly the size of Australia near the North Pole, and Aphrodite Terra, an even larger region roughly the size of South America that runs over the equator, are two of its surface characteristics that are named for both real and legendary women. One mountain is taller than Mount Everest at 36,000 feet, or 11 kilometers. Notably, Venus has by far the fewest impact craters of any rocky planet, with the exception of Earth, indicating a young surface. On your tour of Venus, during the 117 days you're waiting for sunset, you might stop by a volcanic crater, Sacagawea, named for Lewis and Clark's Native American guide. Or stroll through a deep canyon, Diana, named for the Roman goddess of the hunt. Other notable features of the Venus landscape include pancake domes up to 38 miles wide, or 62 kilometers, produced by the eruption of highly viscous lava, with flat tops and steep sides. Tick domes, strange volcanoes with spreading spurs that, when viewed from above, resemble their vengeful namesake. Tesserae, an area of Venus with complex patterns of ridges and grooves that suggest the planet's extreme heat causes rock to behave in certain ways more like peanut butter underneath a coating of dark chocolate. The Soviet Union successfully landed 10 probes on Venus' surface, although even those handful that were able to operate were only successful for a short time. The longest survivor lasted 2 hours, while the shortest lasted for 23 minutes. The environment is bleak, dark, and rocky, and the sky is probably some shade of sulfur yellow, according to photographs taken before the landers perished. The atmosphere of Venus is very diverse. Venus has the solar system's hottest surface, outside of the Sun itself, and is even hotter than Mercury, the planet closest to the Sun. Your wandering sojourn on Venus would probably include unbelievably powerful protection when temperatures rise above 900 degrees Fahrenheit, or 482 degrees Celsius, to outlive the short-lived Venera probes. To avoid being crushed by the weight of the atmosphere, which would press down on you as if you were 0.6 miles, or 1 kilometer, deep in the ocean, you would require an incredibly thick, pressurized outer shell. With sulfuric acid-containing clouds, the atmosphere is primarily made up of carbon dioxide, the same gas that causes the greenhouse effect on Venus and Earth. And the heated, high-pressure carbon dioxide acts corrosively at the surface. But as you ascend higher, a stranger change starts. Pressure and temperature start to decrease. This is Venus, our beautiful morning star.